Hi everyone, my name is Mackenzie Gibson. I'm the current president of the BoardSport Technologies enterprise, BST. As an enterprise, our focus is directed at engineering, design, manufacturing, and testing of skis, snowboards, skateboards, and other products relating to the board sport industry. First, I would like to introduce Josh from our snow team.
I am Josh Penrose, and I am the snow team lead for BoardSports. Our objectives this past year were to design and manufacture a ski and snowboard core press and create a new geometry for a snowboard. This is because when you order a ski or snowboard core, it's going to cost around $40, and that is going to be the single most expensive component of a ski or snowboard. By producing these cores in-house, it gives us the freedom to create our own geometries, much like the one you see on the screen that we designed in the fall. Last fall, we performed FEA on the core. It is our hope that once we confirm the FEA results with our 3-point bend test results next fall, that we can change up the materials for the core model on the FEA and look at different combinations of wood layups to produce better cores. We are currently in the process of cutting out these cores. We hope to produce 6 to 7 cores when done. If we can produce 6 cores, we will be saving $10 per core compared to the $40, and we would be saving roughly $14 per core if we can produce 7 cores. Moving forward next fall, we need to finish cutting out all the cores and then pressing a snowboard and testing them.
Next is Andrew from our skate team.
I'd like to start off with talking about our project, the Everlasting Skateboard Deck project. We essentially designed 3 different prototypes of new skateboard decks that would be able to handle stress at higher loads and deflect less at higher loads than current on-market skateboard decks. This picture that we're looking at right here on the screen is from our stress test that we did in NX. Prototypes included materials such as carbon fiber, ABS plastic, fiberglass, materials that aren't in your typical 7-ply maple hardwood skateboard deck. We use these different types of materials to essentially make a stronger skateboard deck. And on this example, I think the max stress seen was in the middle of the skateboard deck, and it was around 14 KSI. So moving on, we had to change the way that we were applying pressure. The press we planned on using was the portable skateboard press, and the jack in the press did not work, so we had to buy a new jack, and we decided to go with using a scissor jack. We then had to figure out how to gauge the pressure in this jack, so we used a universal testing machine seen here, and we were able to get the torque versus force from this universal testing machine using a torque wrench to about 1,500 pounds. That's what skateboard decks are pressed at, and this machine was telling us what pound force it was off the torque. That's how we came up with this graph. And to the left is the first skateboard deck that we actually were able to manufacture after the board is pressed for 24 hours. We were planning on creating our prototypes that we designed, but due to not having access to the machine shop, we are not able to do so. And we are now kind of rescoping our project, and we're going to come up with a solution to razor tail in skateboard decks, which is the wearing in the tail of your skateboard deck because of stopping.
Next, we'll be hearing from Sam from our wake team.
Hi, I'm Sam Gaffney, team lead of the wake team, which includes members Alec Kasaka, Brian Bigelow, and Faith Scouchet. The goal of our project was to create a hydrofoil that could be attached to any size wakeboard and removed with ease. Our objective is to attach and detach our hydrofoil with minimal damage to the board. Only retrofitting to the board is a small connector piece that attaches to the bottom of the board. Our other objective is to reduce the cost of the hydrofoil. Instead of buying multiple $1,000 plus hydrofoils, ours is a one-time cost around $500 for the consumer to attach to any of their wakeboards. We used 2 methods of calculations to validate our design. The first was a hand calculation that yielded a lift of between 8 and 17 miles per hour, and also yielded the stress on the wings that was below the stress of the materials. The other validation method we used was the fluid analysis feature on NX. This test also confirmed that our material would not yield even under twice the real-world forces. In the fall, we plan to start manufacturing our prototype. We have all the computer work done, just physical manufacturing to move forward.
The first of our 2 senior design teams is the automated snowboard press.
This is the Automated Snowboard Press Senior Design Project. Here we have our team members, Andy, myself, Clayton, Lance, and Mackenzie. Project significance is to improve the manufacturing process of snowboards for BST's future members. In doing so, this will help us produce higher quality snowboards at a faster rate. Here we have a brief project background. We determined our problems to be an outdated heating element, limited workspace, epoxy amounts, air control, and a narrow cat track. Here we have a layup of the current snowboard press. Our solution being implementing 2 heating elements, a lift system, pneumatic air valve, an epoxy chart, and a wider cat track. The heating element layup consists of an upper heating element assembly, a snowboard layup, and a lower heating element assembly. This is our electronic schematic. Please read the schematic description on the slides. This is a CAD model of our pulley system design and snowboard press. Here we have FEA validation with a max displacement of 10,007 inch. Here we have stress, the max stress of 2,646 psi. Here we have the implementation of our pulley system. Here we have the implementation of our pneumatic air valve and air hose assembly with a schematic in the upper right-hand corner. Here we have an epoxy chart and test plan, as well as the type of epoxy we chose. This is a General Motors funded project, and they funded us a total of $3,160. We have a remaining budget of $636. To complete this project, we have to assemble the cat track, assemble the heat blanket, manufacture our snowboards, perform a 3-point bend test till fracture, and then analyze the yield strength results from those bend tests. So unfortunately, due to the COVID-19 pandemic, we were not able to complete this project in spring 2020. It will be continued in the fall of 2020.
Our next senior design project is the snowboard teaching device.
Our senior design project is the snowboard teaching device. We are wrapping up our first semester of the design process right now, and our objective is to create a teaching device that will decrease the amount of time it takes to properly and safely learn how to snowboard. I am Josh Penrose, and I am majoring in mechanical engineering.
I'm Sam Gaffney. I'm also majoring in mechanical engineering. We have 2 other BoardSport members that are helping us with this project, Ben Jewell and Sophie Miller. Snowboarding is a difficult sport to learn with a large initial learning curve. Because of this, ski hills see low repeat numbers and lead to loss of revenue. Our snowboard teaching device will reduce the time it takes to learn how to snowboard while also making it easier. After some market research, we found there is no similar product. The first thing we did was to visit Mont Ripley and take measurements of riders of various ages and sizes to create a chart to estimate how long our telescoping arm should be using a line of best fit between height of rider and their estimated telescoping arm length. Using this line of best fit, we are able to find the estimate of how long the arm has to be for each height, also how to use the fine adjustments for the exact fit.
For the design, we'll be taking load cells and placing them on the bindings of the snowboard. There will be 4 load cells per binding, and these will act much like a standard bathroom scale will, and they will sense the weight distribution in between your 2 feet. When you are snowboarding, it is very important that you keep a majority of your weight on your front foot, and this is one of the biggest problems beginning snowboarders have. So this is why we want a 60% weight distribution on your front foot and a 40% weight distribution on the back foot. When the load cells sense at least 60% of your weight on the front foot load cells, it will send a wireless signal from the Arduino to another Arduino placed inside of the telescoping arm, which will then have LEDs light up green to give the rider feedback that they have proper weight distribution. However, if they have too much weight on their back foot, the LEDs will light up red and the handle will vibrate. The telescoping arm will be adjustable, as mentioned before, as this will give us a large range of users. And then there will be suction cups to secure the parts of the snowboard teaching device to the snowboard. This way it can be easily placed on any customer's board. The estimated budget for this project is around $400. And moving forward, we are currently working on the FEA. Then next semester when we return, we need to order all of our materials, get the electronics working, manufacture a prototype, and test it with a person that's never snowboarded before and the end of next fall.
Thank you so much for your time.